Good afternoon, everyone. Welcome and thank you for joining us today for this SUT Plus hosted webinar, exploring the foundation installation of offshore wind farms with Thomas Sammut from Seaway 7. Thomas shall provide us a background on fixed wind technology, as well as covering installation principles in a project case study. Firstly, I'm just going to give you a brief introduction to what we do at the Society of Underwater Technology. So the purpose of the SUT is to bring together different organizations and individuals with a key interest in underwater technology, ocean science, and offshore engineering innovations. In collaboration with the SUT, we have the SUT Plus, which places an emphasis on the development of young professionals, whether it be graduates in the early stages of their career or students alike. The SUT allows them to have a hand in on the subsea industry. So our aim is to effectively introduce new products and technologies within the industry, all the while developing professionals along the way, out with the usual traditional office environment. We host events and webinars, much like this one today, to extend our reach, spreading the word, and continuously tracking the goings on within the subsea industry. On the 13th of July, we'll be hosting another webinar like today on the green life cycle of decommissioning. And we are also hosting a site visit to Fugro Remote Operations Centre on the 27th. If either of these are of interest to you, please do get in touch and keep an eye on our socials for other future events. So you can find us also through our website at sut.org, or provided here is our email if you have any questions or queries following today's webinar, or inquiries regarding future events, or if you'd be actually keen to host an event yourself, then please do get in touch and we can see what can be arranged. You may also find other webinars and previous ones at our YouTube at SUT Media. So just to summarize, the grand purpose of events like these today is we are keen ourselves to learn more about the industry, and by you being here, you are too. And so I hope you enjoyed today's offshore wind farm presentation. If you have any questions throughout, please use the Q&A function box, and we shall come to the questions at the end. So without further ado, I shall pass you over to Thomas Sammut from Seaway 7.
Thanks for the introduction. I'll just share my screen right now. Good afternoon, everyone, and welcome once again to this presentation for the Society of Underwater Plus community. I'd like to start by saying a big thanks for making the time today to dial in, and it's really encouraging and great to see so many of you. The audience or the attraction, I think, really signifies how much this industry has grown in relevance and also how important it's become. So, as was circulated in the agenda online, the following will be touched upon. So I'll give a short introduction of myself and give some background. We'll take a moment to explain the business, that is Seaway 7, and then define what is a fixed wind, offshore wind turbine, and then relevant technologies underpinning the principles of installing one of them. And then that also culminates in one deep dive storyboard of installation methods to try and paint a picture of how bottom fixed foundations are installed in practice. And then hopefully there'll be some time as well for some Q&As at the end. So yeah, if you have any questions, feel free to post them in the comment section. So a bit of background about me. I studied mechanical engineering and focused on marine and naval aspects, going into an exchange and then a master's degree. And in that master's degree was sort of my first taste in fixed and floating wind challenges, looking at design, T&I, socioeconomics, and cost. And then going into my sort of career, quite lucky to have worked in several sort of industries in this sector. So starting off as a junior naval architect, working in fact on the Erebus, which is part of the Sir David Attenborough Polar Research Vessel, British Antarctic Survey. Then went on to work on towed systems within Subsea 7, and more recently focused on offshore wind installation, which is basically what I'm talking about today. I think the common underlying elements in there are the marine environment and the engineering aspects of all of these different technologies, and finally also the construction and installation. So about the business, Seaway 7, if you don't know, is a leader in the global presence in the offshore wind industry, focusing on bottom fixed foundations. There's a high-tech fleet of 12 vessels, 2 of which are being built as we speak. Manage various types of and sizes of projects, providing flexibility in what we offer from the project management, risk, and engineering capabilities, as well as the actual execution offshore. And yeah, I think one of the key factors there is our flexibility in trying to find the solution with developers from an early stage is something we are strong at offering. I'll get into details of the vessels later on, but you can see that there's 4 main categories: the cable lays, the heavy lift vessels, jackups, and heavy transportation vessels, and they all serve a purpose in the full offering that Seaway provide. Yeah, we come with a track history of firsts in the construction and innovation, I guess, fields. You can see there now over 10 years of experience, starting off in 2009 with substations, and not soon after the first foundation for wind turbines installed by Seaway 7. Then moving on to involvement in other key aspects, such as the cables, the floating wind side of things, getting involved in different types of contracts. You can see there EPCIs, TNIs, etc., large ones as well. And then finally, on the bottom half of that slide is gives you an idea of the vessels we are involved in. So yeah, bespoke vessels for the wind industry, and then they're exciting to be part of. Following on from that, again, further illustrating the experience, you can see a snapshot of the amount of projects we've worked on, completed. That's over 30 now, over 1,250 foundations. Those are monopiles and jackets. Also tripods, I think, are in there. Over 1,200 cables, over 30 substations, over 3,350 kilometers of cable. And then finally, over 15 gigawatts of installation or support of that. And just to give you perspective on what that means, we're currently working on a big project called Dogger Bank, which will eventually become the world's largest offshore wind farm, and that will have capacity of 3.6 gigawatts in total, and that is estimated to power up to 6 million homes. So yeah, linear sort of simplistic view, if you take that 15 gigawatts, that's over 30 million homes. And again, you can see that the clients we're working with, the largest and those that have the most involvement in and around not just the UK, but the world afar. Our reach is global, so we've got operational offices from the west to the east, and also some sales offices there, basically targeting projects in all the regions, identifying where we can provide most value. There's over 600 of onshore personnel, and we're growing. And there's also a good number of offshore workers, over 400 at present. These are consisting of experienced teams of marine and operational construction crews, which are there to deliver the projects we commit to for our clients. As you can see, if I give you a bit of an explanation of the fleet, looking at the bottom, we've got our offshore cable installation vessels and support vessels. They can install inter-array cables and complete all the pull-ins for basically hooking in the foundation to the grid. And then on the left center, we've got a jackup, which is currently being built, and that will be our first vessel to install the tower sections of the wind turbines. And then in the center, we've got the 2 workhorses, if you like, just now, the Seaway Strashnov and the Udin, and they're capable of installing all the different foundations and substations with the respective cranes, Strashnov being 5,000 ton capacity and Udin being 2,500. On the right-hand side is our second new build, which is the Seaway Alpha Lift, and that is maybe a step change in the installation of foundations for not just us, but the industry, trying to increase the capacity and what is possible in terms of efficiency and commercializing projects for our clients. At the top, you can see one heavy transport vessel out of the fleet of 5, and they play a key role as well in transporting the foundations from wherever they're built to the marshalling yards for picking up by the heavy lift vessels later. So you can get foundations on some of the projects we've currently been working on in the Middle East and China, and they need to be transported to Europe. So you need that capability in there as a means of building the wind farm. Moving on now to fixed wind technology. And well, simplistically, your offshore wind farm may or may not look like this. You can split it into 3 main parts. That's looking from the bottom up. You've got something in the ground. In this case, it's a monopile. You could also have a jacket or even a pin pile connected via jacket into a jacket. In the center is what we call the transition piece, and that typically fits over the monopile. And you can see there it says grouted connection. However, you also see now bolted connection or mechanical bolting, fixing those 2 pieces together. And then finally, above the transition piece is the wind tower, nacelle, turbine assembly, and blades. And for us right now, our focus is on 1 and 2. However, 3 will be coming in the near future once Ventus becomes online. Should also add that today's presentation will focus on mainly 1 and 2. So what is the bottom fixed foundation? Why was I so specific in the title before we advertised it online? Well, the focus here is monopiles, jackets, and it can also be gravity-based foundations and suction buckets. At present, I think the lion's share is monopiles and jackets of 3 or 4 leg design, depending on the physical requirements of the field. We tend not to get involved in the design or the decision making of that. However, then we get involved in how do we install them. And as I said, the case study, which we'll go through later, we'll try and focus on that installation method for the monopiles, touching also on the jackets briefly. So Seaway 7 and other companies are obviously interested in this industry due to the rapid growth that's expected. With it comes larger structures, becoming more cost focused as well. So it's very, very competitive. And yeah, there's a big need for efficiency and moving towards offering clients and developers the full package with the assets we've got. You can see right now in 2022, a lot of the installed power is over in Europe with some in Asia, but you can see that over the next 10 years, there's a big upward trend, not just in Europe, but also elsewhere. And that's really why we're looking at all the different locations across the globe and trying to get involved in those respective wind farms. I just wanted to touch upon the debate between fixed and floating. I won't go into too much detail about the latter because that could take its own hour-long presentation. But I guess the main reason why I've focused here on bottom fixed, and also Seaway 7 is focusing itself on bottom fixed foundations, is that they did require different technology, and also working philosophies are different between the two. If you look at floating wind, then there's pre-installation of turbines, pre-commissioning before a wet tow, and there's also different means of transporting them. The 2 foundation types are designed for different environments, so the water depth comes into it, and also the weather conditions. The further out you go, the harsher it can get. And then also the vessels and the equipment you require will also vary for installing these 2 types of technologies. There are some synergies between the 2, and in terms of foundations, You see suction caissons, for instance, applied to both jacket structures, which are bottom fixed, and also anchor points for the floating wind. And also there's the synergies there between cables and the installation. It's good to mention that monopiles have come a long way in terms of their size and weight. So we can get studies now looking at monopiles up to over 2,000 metric tons, wall thicknesses of up to 150 mil, bottom diameters of up to 11 meters, and lengths over 100 meters. The largest, I think, right now being looked at, the XL monopile, sorry, but also the XL and the XXL, is that 11-meter diameter. And there's challenges with going higher than that. Practical ones such as logistics, installing it, and also the issues which are related to the design, so the buckling effects and the bending. So focusing back on bottom fixed foundations and the installation principles behind them. Excuse me. So our inputs may include the vessel type when thinking about an offshore wind farm, whether it can be jack-up or a floating vessel, the motions that come with it, the deck space you've got for all the equipment, and then the crane capability, so the load and the radius. You've also got things like the mission equipment on board, so that may include upending frames, hammered technologies with the sleeve, storage and handling of these monopiles and transition pieces, potentially a template for installing pin piles, and grillage. Finally, project-specific equipment like lifting tools and bolting tools is also needed, and then there's also rigging. So all these different considerations and how you can get it to the work site offshore in the most efficient way is part of the big puzzle and the logistical effort that takes place when planning these projects. One of the great things I've found with working with this industry is the amount of multidisciplines involved, and all the inputs are required for the successful outcome of the project. High level, you can look at a project being the core or the key interface between all these different disciplines. Structural guys looking at rigging design, FEA, sea fastening design, grillage design, and equipment. You've got geotechnical feeding into the forecasting for hammering, and that also has to do with the risk of a project and whether we will be able to install within the timeframes we think we will, preventing drop falls and any scheduling challenges. Things like naval get involved to work out the stability of motions and, importantly, the workability to install these structures. They input back to structural as well. And other disciplines such as design and technical equipment will give detail and basically build the storyboard and the checking for our final deliverable. And it all comes together in the planning and the logistics, as well as the documentation and certification provided to the client. So moving on to the case study now, and my focus was to give you a representative field. So we chose this one, which was a wind park in the North Sea, close to Germany. 38 wind turbine foundations and one substation in relatively shallow water, I'd say, and an integrated offering, meaning we provided for the planning and engineering for the transport and installation of all the components. Just to give you an idea of a field layout there, you can see the within that yellow ring are the fixed wind foundation locations, and between each one are the inter-array cables, all feeding back to a substation. That substation then is connected to a main high voltage line going back to shore. If you can look to the right of that on the bigger map, you can see the field, part of a larger cluster, and a route there for O&M during the life to Heligoland, and also the operational base on there as well. So in our planning, we take into consideration where these foundations are being built. In this case, they were built in Europe, up in Aalborg. For us, the most efficient way of installing this field was to transport these foundations down to Eemshaven and then pick them up via HLV and take them to field. So you can see there that there's a requirement to move these foundations via barge and tugs, and then the HLV does the rest. One thing to keep in mind with the schedule and the logistics is typically some foundations or all foundations will require scour to prevent seabed loss. And depending on the type of system and technology, you can have filter layer, armor layer, and that will come before the piling. So in this case, you have to think about the HLV and when its availability is planned, and then make sure that there's no bottlenecks in available locations to start installing before the scour is installed. Talking about the HLV, one of our first tasks when execution starts is to bring the vessel alongside. We install the grillage and the structures onto the main deck, prepare and test all the equipment, including the different spreads, hammers, noise mitigation, survey, etc. And there's also upgrades. So we've got R&D teams within the company that are looking at the next improvement to our process and our methods. And yeah, typically you can have these sort of mobilizations alongside a project mobilization, and it's all to do with improvement with our technology. Once the vessel's mobilized and ready for the project, it will then move to the marshalling yard. We said it was Eemshaven in that example earlier. That's where it will pick up the monopiles. This can be done inshore or offshore, depending on weather and workability. Typically, monopiles are brought in horizontally with high-capacity spreader bars and Dyneema rigging. And as an example there, I also showed a photo of a jacket, which was basically brought in by barge and installed directly in field. So like I said, it can be both an inshore or an offshore operation. Again, comes down to the logistics and capacity of the deck. So transiting to field, what we think about is the distance. We're looking at the cycle times to go around, pick these foundations up, take them to field, or bring them there to the vessel. We're trying to utilize the amount of deck space we have as much as possible. We're thinking about what vessels to bring along with us, the type of environment we're working in, and obviously the technology we have available to us. On arrival, there's generally two ways of setting up for our vessels just now, and that's installation and positioning on anchors, or now installation on dynamic positioning. And where I mentioned their technology, this has been a big push in the company to basically become a key enabler to bring future wind farms more commercial, is by installing on DP and lowering our cycle times significantly. And when I say installation on DP, you can see in the photo there what we call the gripper. I'll mark it with a red laser point there. And that is a system that handles the monopile in the vertical orientation and allows for some degree of movement whilst we hammer down into the location, whilst the vessel is running just on its dynamic positioning systems. And that just means there's less vessels required, like anchor handler tugs, to install anchors, and it also reduces that amount of work that comes with installing anchors and removing them. So once we're in position, we typically use either an internal lifting tool or a vibro lifting tool, stabbing it into the monopile and then using it as the swivel point for our single point of lift. The storage frames you saw, one of them is a bit special in that it's also an upending frame, and that partially supports the monopile weight whilst it's being brought into its vertical orientation. A few more photos there of it being brought around. Worth mentioning that this tool you see here is another sort of technological advancement in that we don't need to swap around tools. We can upend and vibrate down the pile without changing over equipment. And it's yeah, very neat in that it can support now these larger monopiles. Initially, this technology was used on pin piles and smaller piles, but now it's coming up to the larger foundations as well. So what is vibratory driving? Once we bring the monopile vertical, we lift it into the gripper that I mentioned earlier, and after setting the pile down onto the seabed and letting it find its own self-weight penetration, we can then run the vibratory hammer. And the principle there is by vibrating the pile, that then reduces the friction, liquefying almost the soil immediately around the pile. And that is a key principle in terms of once you've reduced that resistance, the weight of the pile is then again sort of left to do its own thing. The crane begins to lock down, and those two principles there will allow the pile to drive into the seabed. And that also gives you there a nice picture of what's happening in stages. To the right are some typical operational photos. You can see on the bottom right is final penetration for a pile. Not this one, but giving you an idea there of how it may look. We've got lines on the piles as visual IDs sometimes. And then top right, I've actually borrowed that photo from an impact hammer operation, which I'll come to on the next slide, but that is used for final penetration and survey when we're hammering down. So speaking of impact hammering, this is a slightly different technology in that it uses an internal ram, and it's accelerated into what we call the anvil, and transfers potential energy to kinetic energy through the pile. And you get these blows into the thousands. Per blow, you get penetration of a few centimeters sometimes. And after enough blows of energy, then you get to final penetration. This technology can be used standalone, so you don't necessarily need vibratory driving, but what we're seeing, or what we're looking at is using vibratory driving due to the efficiencies and not requiring other tools, and also the speed at which hammering occurs is swifter. And also with impact hammering, although it is the traditional sort of technology, there are some challenges that come with it. One being noise. and that's where noise mitigation systems come in. So for mammal and environmental protection, we use deterrent systems, we use energy absorption systems. There's ongoing surveillance of the noise levels, and we of course have the energy control going through our hammers. Going from number 1 down, so deterrent systems basically work on the principle that we alert the surrounding mammals in the vicinity that we will begin hammering, and there are systems there we can use to in advance of starting the hammering to notify the mammals, if you like. For energy absorption, you can see there on the photo a far field bubble curtain, and you also get near field bubble curtains immediately around the monopile. You can also have them used together to increase that energy absorption. Typically, you have vessels installing hydrophones to monitor the noise around the field, and then that feeds back into our energy control, where we limit the amount of energy going through the impact hammer to stop noise levels going any higher. So that's pretty much the installation of a monopile. For jackets, which are installed via piles, it's a similar process where you install pin piles and then a jacket's installed over. Or what you see again nowadays is jackets with suction caissons, and they use a different working principle where they create a vacuum between inside the caisson and the seabed and suck itself down. But the principle there is similar in that the heavy lift vessel is lifting that foundation and placing it over the final position. Once the monopile is installed, typically there's secondary steel and structure which needs to be installed. You can see there the boat landing on the left-hand side being transferred over onto what we call a boat landing installation frame, and that basically gives us the accuracy for installing these boat landing ladders in the right position on the monopile, and also gives us the orientation correctly. Once that's done, you can then install the transition piece, and there's a few different designs. Some are called short-skirted transition pieces, some are long-skirted transition pieces, and they range in weight from 200 to 800 tons, depending on the type of foundation we've installed. Again, the means of installing these are using that single point lift, ideally with a spreader bar or some other lifting tool. And then you can see some tugger lines or steering lines connected in order to get that orientation correct. So once a TP has been installed, there's two options again. The HLV can stay on location to do completion, or the HLV can leave and a secondary vessel can come in to complete the remaining tasks. And that second option is seen as more beneficial because you're maximizing the use of that heavy lift vessel, and there's less of them, so you want to keep it busy lifting as much as you can. So there's these walk-to-work systems which you can get either installed onto the back deck of an HLV, or ones which are integrated already on designated vessels. And this has become, I guess, the industry standard in terms of bringing people onto the TPs to do the completion works. If you think about escape routes from a foundation, safety, taking the equipment across, and also the workers' welfare, these systems are very good at moving people between vessel and the work site. Sorry, can you still see my screen? Because mine has gone blank.
Yes, we can.
Perfect. So speaking about completions, what I mean there is the physical bolting or grouting of the transition piece to the monopile. And that can range in the number of bolts depending on the design and size of the monopile, but the ones I've seen can have in excess of 100 bolts. You can also see that there are other locations where that technology is used between the towers, the sections, and the TP, and also the tower sections standalone, but we don't get involved in that too much. Other types of tasks are the connection of the systems, such as earthing and repairs. And then finally, we prepare for handover to the cable and tower teams respectively, which is where the walk-to-work vessel then leaves the field, and we hand the location back to the client or the next team coming in. So to sum it all up, I think the focus here now is technology, looking at turbines and foundations. There's a huge scalability in the last 20 or even 30 years. If you look at that slide, we've got to match and then push those boundaries with the assets we've got, and also the equipment that comes along them on the vessels. In terms of what we're aiming for is the effective and efficient execution of these projects. So again, to conclude, that comes with smarter solutions, so different ways of working, standardization of the different foundations, which we are seeing as well, and getting into that production mindset to ensure that cycle times are brought down and the reliability or predictability remains high. And that brings us to the end of my slides. I want to thank everyone for your attention and hope that there was something of value in there for you today. And I can take any questions if you have any. Thank you.